second-year PhD student at Stanford in the cancer biology program. And I'm really excited to talk to you today about my somewhat unexpected and incomplete journey to becoming a scientist. So I think I noticed from your club's website that you've had a lot of older speakers, people that already have careers in the sciences. So what I'm going to show you today is kind of my journey leading up to grad school. And there's a little bit of stuff about what I'm doing now, but I mostly want to tell you guys more about like how did I choose to study science in undergrad, what did I do in college besides school, etc., etc. Feel free to stop and ask questions whenever you want. And then I think there should be time at the end also to ask questions. Okay, so I grew up in Irvine, which is kind of similar to Palo Alto. It's in Orange County, for those who don't know. So Southern California. I went to high school at Irvine High School, home of the Vaqueros, woo. So at this time in my life, I knew I was good at school. I liked science, but I wasn't necessarily like super gung-ho about knowing that's what I wanted to pursue in the future. And so besides taking all my AP classes and honors classes and trying to do really, really well there to set me up for college, I was also involved in sports. So I played soccer, and I did lacrosse, which was actually new at my high school, so that was really cool. But by far the thing that had the biggest impact on me in high school was band. So there's me in the front. I was band nerd to the max. It was by far like the best experience I had in high school. And I was super nerdy because I was actually drum major of our marching band. So I don't know, do you guys have a marching band here? Yes? Yeah, marching band! Okay, so you will see a theme throughout my presentation where band has had a huge impact on my life, and I would say probably even more so in science in terms of my personal relationships and people that have impacted me as I've gone through this journey. So that being said, when it came time to choose what to do in college, I had this huge quandary because I really liked music. I played the trumpet, and I really enjoyed it. It was definitely like probably, I would say, my biggest passion at the time. And I really liked the idea of teaching, and I loved my band teacher, and I was like, if I could do what he does for the rest of my life, that would be awesome. But that being said, like studying music and pursuing music as a career is obviously very difficult. You have to be very talented, very select few actually make it. So I also knew that I was really good at science. So I really liked biology. I really got into cell and molecular biology when I took AP biology. Do you guys have AP biology? Yes? Okay. Has anyone taken it yet? How is it here? Is it like super hard?
It's really easy.
No. It's really easy. Okay. It really changed. It depends on the school.
Yeah.
So AP Bio for me was definitely where I first was really interested in like how cells work, and I thought it was super interesting how all these chemical reactions lead to like a self-sustainable living unit, and I thought that was super cool. And in general, I was good at the STEM fields, so math, science, etc. So from a more practical standpoint, it seemed like science was probably the better way to go. And after a lot of hemming and hawing, I ended up deciding to pursue science, mostly from a more practical standpoint. Like knowing like, okay, where am I now amongst all trumpet players, and how am I going to be professional? I said, okay, maybe that's not the most practical way to go. So I instead decided to pursue science. And then the next question was, where do I actually want to go to school? So what is like the age group here? How many seniors do we have? And juniors? Okay, and then sophomores? Freshmen? Okay, cool. So towards the older end. So these are things that I thought of, and obviously everyone has different criteria, but these are the things I considered. So first you need to figure out where you want to apply, right? I say academic ranking, like not like the strict numbers, because they all change depending on who you ask, but in terms of like for my academic standing, what was a reach school, what was like a pretty good school, what was a safety school. So I made sure I had a mixture of all of those. I applied to a few Ivy Leagues, a lot of UCs, and some Cal States. Because I wasn't exactly sure what I wanted to do as a career, I wasn't even thinking of a career at this point. I was just thinking, what do I like to study? I made sure that the colleges that I applied to had multiple things that sounded interesting, because I didn't want to go after one specific major and end up hating it and not have any other options at that school. And then also extracurriculars I wanted to join, such as band and intramural sports, things like that. And then location and cost were always in the back of my mind, but they weren't like biggest factors for me personally. And then once I had gotten my acceptances and I had decided where I wanted to go, I highly recommend touring places you're really considering. And things like the area around the school, like could I see myself living there? Do I enjoy being in a city? And then do the students there seem happy? Do they seem fun? Is this a place where I'm gonna fit in? So I wouldn't say where I chose to go to college was necessarily career oriented. It was more so where do I see myself fitting in? Is this a place where I can be myself and I can also learn at the same time? So that being said, my top two choices were Cal, or UC Berkeley and UCLA. And there may have been some bias. So I grew up a Bruin baby. Both my parents went to UCLA. And so I like to say that didn't influence my decision, but it probably did a little bit. So in the end, I ended up going to UCLA. I went in with a major already chosen in molecular cell developmental biology. And I did that because, one, I didn't want to apply undeclared. People have different opinions of whether or not that helps or hurts you. I still don't know what the answer is, but I personally said I don't want to be undeclared. And I'm one of the few people who never changed my major. So I happened to pick something. I literally picked it because it had this word molecular in it. And there are so many biology majors at UCLA. I was like, how do I choose one? And I knew what this word meant. And I knew that I liked AP Bio. So I said, okay, I'm going to pick this major and change it if I want to. And I never wanted to. So I was lucky in that case. But changing your major in college is really common, and a lot of people do it. And it's not a bad thing. So that's what I ended up studying. So first thing, of course, when I got to UCLA, the first thing I did was join the marching band. Ta-da! So there's me. I think I'm like right there. So this, again, was by far what had the biggest impact on my college experience. I also joined a co-ed fraternity called Kappa Psi. It is a service-based fraternity rather than a social fraternity, so we did a lot of music-based community service. So we helped out the marching band, we helped out bands in the community, etc. And again, I was the nerdiest of the band nerds because I was president of Kappa Psi my senior year. So, like I said, this by far had the biggest impact on my life in college, and I highly recommend for those who are, when you first go to college, find something that you like to do and find your group early on that's outside of class, because this will definitely be your closest friends and have the biggest impact on your experience. So just to prove that I also did other things besides band, UCLA is also really fun because you're right near the beach. You have a lot of things to do, like hiking to the Hollywood sign, etc., etc. If you guys have any questions about UCLA, I'd be happy to answer them. So now for the things related to why I'm presenting to you guys, how did I get into research? There's lots of different ways you can do it as an undergrad. If you know from the get-go, like you already know you want to do research as an undergrad, I highly recommend going to a research-based university. So like all the UCs are research-based. Stanford is a really heavy research university. If you go to a liberal arts college, your research opportunities will be more limited. So just make sure to keep that in mind when you're choosing where to apply. Once you're in undergrad, there's lots of different ways you can find out about research. There's sometimes some universities have student clubs or peer mentorship programs, which is what I did. I joined a club whose purpose was to help freshmen get into research. There's also undergraduate research programs through your major. Like they'll have professors that want undergrads to work in their labs, sign up for this program, and then you can find them that way. Or you can look up the labs that interest you and email the PIs or the professors in charge of that lab directly. So I did like a combination of all three of these, but the main point is that if you want to do undergrad research, you have to go find it. It's not going to find you because it's extra. It's not required for your major, so you just have to go and pursue it yourself. So that's what I did. I emailed at the end of my freshman year. I had a little bit better sense of what research was, and I thought the idea of learning things that people had never known before, going to the lab and finding something new every day seemed really cool. So with that, I emailed a bunch of PIs directly and ended up in the lab of Michael Teitel. He was my undergraduate advisor, and in his lab, I worked for 3 years on a project, and by working on one project for a really long time, I not only developed a good mentoring relationship with him, but I also got to dive really deep into the science. And during that time in the lab, I was also part of the biomedical research minor at UCLA and the Amgen Scholars Program, which is a summer research program for undergraduates. So by doing these extra things besides just lab itself, these are what really provided the resources I needed to become a well-rounded scientist and to also decide whether or not I want to go to grad school. Because these undergraduate research programs, whether they're through your university or through outside organizations like Amgen, they're really good at providing you with resources of how do you apply to grad school, how do you pick a grad school, etc. So it was really through these experiences that I kind of made my decision to go to grad school. And just a little bit about what I did for my undergraduate research. It was looking at the intersection between stem cell metabolism and differentiation. So pluripotent stem cells are cells that are derived from the blastocyst stage of an embryo. So if you take these out of an embryo, you put them in a petri dish, and they will stay as these stem cells and just keep proliferating over and over and over again. And you can actually do in the lab is you can direct them to become any cell type in the body. So these are really cool cells to study, and we're still trying to figure out all the potential that they hold for medicine, etc. So what I was really interested in undergrad is this phenomenon where for their metabolism, or how these cells acquire ATP, there's two main pathways, glycolysis and oxidative metabolism, or oxidative phosphorylation. And it's been known that when they're in this stem cell or pluripotent state, they prefer glycolysis, and when they differentiate, they prefer oxidative metabolism as their main way of getting ATP or energy. And then when they go back to becoming a stem cell state, which you can also do in the lab, they prefer glycolysis again. So my research was really focused on why do they prefer one over the other, and how does the shift in metabolism relate to their ability to become any of these other cell types. And then one really cool thing about doing undergraduate research is that you can become published. So this is the graduate student that I worked with most closely in the lab, and this was actually just published in July this past summer, and I got to be second author. So this was from my undergraduate research. I already get to be a published scientist, which is really cool. So from there, so I knew I liked research. I still had no idea as a senior in college what I wanted to do for a career. So I was like, okay, so what do I do next? Like, where am I supposed to go after this? And I decided to go to grad school really late. I decided like the summer before my senior year of college, and the decision, that's like basically the last chance I have to decide, because the application cycle is in fall. So at the very last minute, I was like, okay, I'm gonna go to grad school, and here's why. In the life sciences, if you want like a really upper level job, or you want to do research for the rest of your career, you really do need a higher level degree. Like I said before, I could see myself being a professor. I really like teaching. I really like doing the research. Doing the hands-on experiments in the lab was something that I really enjoyed. To be completely honest, I didn't really know what else to do at the time, but I thought, okay, at least if I have a PhD, that'll open up my opportunities in the future for continuing in science. And one great thing about life science PhD programs is they pay you. So I get a stipend and my tuition is covered, whereas if I were to pursue a master's degree, that would not be the case, or a medical degree, that would not be the case. So that being said, now that I'm in grad school, my thoughts are a little bit different on how to decide whether or not to go. So this is a little far out from where you guys are now, but I think adding to this, my thoughts now are that don't just go to grad school to fill time. It's kind of scary when you're about to leave college and be like, I don't know what to do, I don't have a job, blah, blah, blah. But PhD programs take a long time. My program is 5 to 6 years. And so if you're just using it to fill space because you're not sure what career to do, it's not really worth your time, in my opinion. If you like to do research, obviously go for it. If you know that a certain graduate program is going to get you to the career you want, totally go for it. But don't just use it as a time filler. Also, don't rush into it. It kind of goes hand in hand. So I went straight out of undergrad. A lot of people take time to be a lab technician for a few years to see, okay, can I do this as a full-time job? Is this what I really want? And it might seem like you're wasting a couple of years, but it's not a waste. It really helps you decide what you want in your life. And also, before you go to grad school, I'll definitely see like what career options interest you, and is grad school really going to help you reach those goals? So then why did I choose Stanford? So my top 3 graduate schools that I was choosing between were Stanford, UCSF, and Harvard. And all 3 of them had a lot of great things about them, and when I interviewed there, I liked a lot of them, or I liked all 3 like a lot. And so the reason why I chose Stanford, as you can see here, so obviously Stanford is a great research university. There's a lot of resources that a lot of other schools don't have. It's a very collaborative environment, both within the biosciences and with engineering and physics and stuff like that, which you don't see at a lot of other universities. When I interviewed here, kind of like when I was picking a college, I didn't know exactly what I wanted to study. So it was important that there were multiple labs and PIs that I wanted to work with in multiple areas that interested me that I could pursue once I got here and figured out what I wanted to do. Obviously the location is great. Growing up in California, I didn't really appreciate it, but after talking to people that have come from like the Midwest and the East Coast, it's definitely good to be in California, weather-wise and lifestyle-wise. And then actually one thing that probably registered the most, which might seem a little counterintuitive, is I just clicked best with the students and faculty here. In terms of a career move, it might seem kind of naive to be like, oh, I like the people here, so I'm gonna choose this place. But everything else being equal, like this is really what made the deciding factor for me. Once again, like I knew my career opportunities would be great going to any 3 of those schools for grad school, but this is where I felt the most comfortable. And I think it's really important to make sure that you not only balance your career goals and trying to go to the best university that you can, but also making sure that you make a decision that'll fit you and make you happy. So where am I today? I am in the lab of Dr. Julian Saj. His lab is very interested in cell cycle, so that's mostly why I joined, is very looking back at the really basic cell biology and how does a cell decide when to divide and when to not divide. There's also more people in the lab doing mouse models of cancer, particularly small cell lung cancer and pancreatic cancer, and there's some people working on stem cell biology. So now that I'm a grad student, what does my typical day look like? So it's mostly experiments. I'm currently doing a lot of cell culture work. I'm not working with mice myself. So it's a lot of biochemistry, molecular biology, cell biology. I'm reading a lot of papers. So grad school is a lot of self-directed learning. So rather than, I don't have a lot of class, but instead I read a bunch of papers. There's a lot of reading involved. It's a lot of pursuing what interests you and what's gonna help you with your research. And then I have the occasional class and also seminars, but once again, the classes that I have to take are pretty much up to me. I just have to fill up units, right? So I have to decide what is gonna help me become the best scientist I can be. And I'm not gonna go too much into this unless you guys really wanna know what I'm studying. So I just started in this lab in the summer. So I'm trying to figure out what I want to do for my thesis project. So in graduate school, you pick one project, you work on it for a bunch of years, and in the end, you write a really long, comprehensive thesis about what you discovered. So my project is looking at cell cycle, and particularly this protein, RB. Do you guys cover cell cycle, like AP Bio? Okay, so some of you know what this is already. So the cell cycle is divided into 4 phases, and basically once you cross from the G1 phase to the S phase, this is where DNA gets replicated. So once the cell crosses here, it's gonna go all the way through the cycle. So it needs to make sure that at this R point transition, also called the restriction point, the cell needs to make sure that it's ready to divide and it has all the materials it needs in order to complete a full cycle. So this protein RB, it helps regulate the cell to make sure that it doesn't enter early. And what it does is it binds to this other protein called E2F, and it blocks E2F. So E2F helps the cell enter S phase by helping the transcription of a lot of different genes, but RB binds E2F and stops it from doing that. So then the cells get stuck in G1, and sometimes they exit the cell cycle in what is called G0. So when cells are ready to divide, this protein complex called with CDK4 and cyclin D, it can add these phosphorylation groups to RB, which then causes it to dissociate from E2F and then the E2F can help the cell enter the cell cycle. So this happens, and then in cancer, this pathway is often overactive. So RB is almost always inactive, and the cell just keeps dividing and dividing and dividing and dividing, and that's why you get cancer, because the cells don't know when to stop. So there's currently been a new drug that has come out in the clinic called palbociclib, and its job is to stop this complex so that RB can be active again. So when this happens, RB doesn't dissociate, and instead stays stuck to E2F, and which then leads to accumulation of cells in G0. So basically you stop the cancer cells from dividing using a drug because they don't know how to do it themselves. And so this drug is relatively new. There's a lot of other genes and factors that are involved in how the cell responds to it. So kind of just broadly what my project is focused on is how are proteins that are similar to RB, how do they respond to the drug? Is it the same thing where they become extra active, or are they doing something kind of different? And then also, what other mechanisms do cancer cells use to become resistant to this drug? Because we know that it doesn't work in every cancer patient. So kind of figuring out why that's the case at the molecular and genetic level is what I'm looking at. So that being said, I still don't know what I want to do as a career. So obviously you don't need to decide right away. You don't need to decide, especially in high school. I'm open to the idea of I could go to academia, I could become a PI, I could become a professor at like a more liberal arts college and focus more on teaching than on research. I'm also open to the idea of going to industry and doing research there. So I think I'm going to definitely use my time in grad school to kind of figure out which of those paths I want to take. So with that, I'm happy to take any questions with the remaining time that we have. So yeah, thanks for listening.
So you said the drug doesn't work on all cancers. Which cancers does it work on and which does it not?
So right now, the FDA has only approved it for use in certain breast cancers.
Okay.
So different types of cancers in different organs obviously are run by different genes.
Mm-hmm.
And then even within that, they can be subdivided into more different types. So in breast cancer, there's like two main types, which is like hormone receptor positive or negative. So right now they work in hormone receptor positive. It's actually really interesting biology. So if you go back to this, oopsies. Okay, so there's this receptor that's often mutated and overactive in breast cancer. What it does, it can actually drive the expression of the cyclin D gene. So then there's a lot of this complex in this breast cancer, so they're very dependent on this complex for the cell cycle to drive it. So that way, when you add this drug, it stops like the main mechanism by which the cell divides. But that's not true of every cancer. So like even if the complex is being used for cell cycle regulation, the cell might rely more so on this complex. And there's so many other, this is a very simplified diagram, right? So there's a lot of other proteins and signaling pathways that interact with this in some way that we don't know completely yet. So it's mostly for breast cancer. It's currently also being studied in non-small cell lung cancer and melanoma. But each type of cancer seems to have its own mechanism of resistance. So it's going to take a lot of research to figure out comprehensively how it works.
Okay. And you guys are just using it in cell culture right now, not on mice models yet, or have you guys gotten into that?
So other people have for sure.
Okay.
So like I said, it's already progressed to the clinical stage. So usually it's like you start it in cells, then you move on to mice, and then you move on to clinical trials, right? So for certain other groups so we didn't develop the drug. It's been out, so I think it was discovered in 2010. Okay. So a lot of people are studying it for sure. What I'm doing is only cell culture work for now. And maybe we can progress to the stage where we can use it in mouse models and see if we can get any combinations of drugs that make them more effective.
Awesome.
Yeah. Any other questions? Yeah.
Since you're doing research, what are some, I'm also in a research class, and so what are your tips for conducting a good research project?
Oh, so like how to do it well.
Yeah, and like communication, especially with like a mentor.
Okay. So I think when picking a lab, to join, that was one of my biggest concerns, was having a mentor that I felt really comfortable communicating with. So it definitely helps you, like I said, it's a lot of self-direction, which I think is very different from high school and even from undergrad. It's a lot more of, every day when I go into lab, my mentor is not telling me like, you do this experiment, that experiment, that experiment. So I have to do a lot of the learning where I read a lot of scientific literature and I decide, okay, what would be the best way to test my hypotheses or to ask these questions. So a lot of it is that, and it comes a lot also from learning from your peers in your lab. So I ask, especially as a new graduate student, I'm often asking the older graduate students or the postdocs, like, how should I design this experiment? And so obviously controls are always important, you know, positive control and negative control, that's like very standard for any experiment. And in terms of communicating with your advisor, you wanna make sure that you ask questions. I think that's the biggest hurdle for me, because I was really good at school and I got A's and I got everything right all the time. It's hard to jump into research where you're wrong like 90% of the time. Your experiments won't work, your hypotheses will fail, et cetera, et cetera. So I think it's important when you're first starting your research to always ask questions. If you're not sure about anything, ask your advisor. Don't think like, oh, they're gonna think I'm dumb if I ask. Like, ask and get the answer right the first time, and that'll save you a lot of time in the future where you're trying to figure things out by yourself.